Hi everyone, in this video we're going to be doing A-level further maths 9231 paper 11 October November 2025 further pure maths 1. This paper is 2 hours long, so we'll try to finish within that time limit. So let's get started with the first question. Okay, so for the first part, we're told to use standard results from our MF19 to find this summation in terms of n, simplifying your answer. So by simplifying your answer, they mean that you either have to basically expand it out fully. Okay, so let's start. So let's start out by copying down our summation. And now, just like when you're integrating or differentiating, you can also split the individual terms in the summation the same way that you would be when you're differentiating and integrating. So you can split all the terms that are in between the plus signs, as well as the terms that are not in terms of R, like basically all the constant terms. So, oh shoot, sorry. Okay, so no. Okay, so doing that, okay, let me do it one by one. You would get this 8r cubed plus summation sign r equals to 1 times n 12r squared plus summation r equals to 1 and 4r plus summation of r equals to 1 and 3. Okay, so now the next step is to take out all of our constant terms inside the summations that are not in terms of R. And then for the terms that only have constant terms inside the summation, just like when you're integrating, you just add whatever variable you're integrating with respect to. So in this case, you just substitute whatever the upper limit of the summation is, which in this case is n. So let's do that. So just take out the 8. So 8 times r equals to 1 and r cubed plus 12 summation of r equals to 1 and r squared plus 4 times summation of r equals to 1 and r plus 3n. Okay, so this is where we're going to directly copy down our standard results. So to go see your standard results, go to further pure maths and look under summations. You would see you would have summations for all three, for r, summation of r and r squared, as well as r cubed, all of which is r equals to 1 for the lower limit and the upper limit is n. So for r cubed is just 1 over 4 times n squared times n plus 1 squared. Okay, so times 1 over 4 n squared plus n plus 1 squared plus, and then for 12, you have the r squared summation. So r squared summation is 1 over 6 times n plus 1 times 2n plus 1. So 1 over 6 times n plus 1 times 2n plus 1, then plus 4 times the summation of r. Sorry. Summation of r is half n times n plus 1. Okay, so this is going to be half times n plus 1 plus 3n. Okay, so let's simplify it, but we're not going to expand yet, all right? So 8 times 1 over 4, that is 2n squared times n plus 1 squared, and plus 12 times 1 over 6, that is also 2. n times n plus 1 times 2n plus 1 plus 1/4 times half, that is 2n times n plus 1 plus 3n. Okay, so now our next step is to factorize out the common term in all of the terms here, and so far I can only see that they all have n as the common factor. So we're going to factorize that out first. So factorizing n, you get 2n times n plus 1 squared plus 2 times n plus 1 times 2n plus 1 times 2 n plus 1 plus 3. Okay, so now we can see that the first three terms, we have the common factor 2n. Wait, no, not 2n, sorry. 2 and n plus 1 in all three of them. So here we have 2 times n plus 1 as well as here, except the 3, basically. So we factorize everything except the 3 in the bracket. So to factorize that, well, let's replace it with square brackets. So factorize out 2 and n plus 1. So that one is going to be n times n plus 1 times 2 n plus 1 plus 1. Yep. Yeah, I believe that is all. Yep. And plus 3. Okay. So now let's expand everything in this bracket here. So 2 n plus 1. So n times n, that's n squared. N times 1, that's n, plus 2n plus 1, that's just plus 2, and plus 3. Okay, almost done. So 2 times n plus 1 times n squared plus 3n plus 2 plus 3. Okay, so here is where we're going to expand out everything. So we're going to first start out by expanding these two brackets out fully. So a shortcut way to do this is to just start with the term with the highest degree first. So in this case, to find the term with the highest degree, just take the terms of the highest degrees in each bracket. So you take n for this one and n squared for this, multiply them, you're going to get n cubed. And then now you start off with the term in the next degree, so n squared. So to get the n squared term, you just have to multiply n with 3n. So that is 3n squared, and for 1, you multiply with n squared. So 3n squared plus n squared, that is 4n squared. And you do the same for the n term. So multiply n with 2, you get 2n. Multiply 1 with 3n, you get 3n. So 2n plus 3n, you get 5n. And then plus the constant term, you just multiply 1 with 2. For n, you cannot multiply with anything, so just leave it at that. So you get 2 for this. Okay, now we can expand it out fully. So just multiply everything by 2, 2n cubed plus 8n squared plus 5 times 2, that's 10n. 2 times 2, that's 4. 4 plus 3, that is 7. Yeah. And now just, expand out the n. So you get 2n to the power of 4 plus 8n cubed plus 10n squared plus 7n as your final answer. So I believe that would be all for the first part. Let's move on to the next part. Okay, so for this second part, we're told to show that this result is true, and hence, using this result, we need to use the method of differences to evaluate this summation. Okay, so for the first part, the showing part, to show like that this result is true, you can do it either way, either from the left-hand side or the right-hand side. If you're going to do from the right-hand side, you're going to have to use partial fractions where you have to be extremely careful. So I'm going to start from the left-hand side and just expand normally. Okay, so let's start. So 1 over 4 minus 1 over r plus 1 to the power 4. Okay, so first things first, make the denominator the same for both fractions. So in this case, you want to just make the denominator as this. So r to the power 4 times r plus 1 to the power 4. So for this first fraction, the numerator would just be r plus 1 to the power 4 minus the second one, numerator is also the same, r to the power 4 times r plus 1 to the power 4. And for this, you multiply r to the power 4. So here, numerator will be r to the power 4. And now we're going to combine them together since they have the same denominator. Okay, so for this one, we're going to have to expand this expression here. To expand this out, we can use the Pascal's triangle to expand it. So for the power 4, the coefficients would be 1 to 1. This for power 2, 1, 3, 3, 1. This for power 3. Power 4 would be 1, 4, 6, 4, 1. So this for power 4. So these are our sets of coefficients. Okay, so the first term is going to be r to the power 4. So times 1, and then plus 4 times r cubed times 1, so just 4r cubed, plus 6 times r squared times 1 squared, which is just 1, plus 4 times r times 1 cubed, which is just, again, 1, plus 1 times 1 to the power 4, which is also just 1, minus r to the power 4. So the r to the power 4 terms cancel out, and you will just end up with 4r cubed plus 6r squared plus 4r plus 1 over r to the power 4 times r plus 1 to the power of 4. Yep, that's the exact result that they give us. So we can write shown in here to conclude our first part. Now we're going to use the method of differences to figure this summation out. Okay, so as you can see, the summation here is basically the exact same result that we proved. Like the term inside the summation is the exact same term that we proved in here. So for the method of differences, you're going to have like two terms that are, subtracting with each other. So you cannot just like start off with this. You have to change it to this form in our case. Shoot. Wait a minute. Okay, so copy everything down. R equals to 1 and 1 over r to the power 4 minus 1 over r plus 1 to the power 4. Yep. Okay. So to do the method of differences, just substitute as you would normally in any summation. So the first term is r equals to 1. So we'll substitute r equals to 1 first. So you get 1 over 1 to the power 4 minus 1 over 1 plus 1 to the power 4. So that's 2 to the power 4. Yeah, just leave it as that. Plus, and now you substitute r equals 2. So 1 over 2 to the power 4 minus 1 over 2 plus 1 to the power 4, so 3 to the power 4. And by now I hope that you can see the pattern. So you can continue this for r equals to 3. So that is, sorry. So r equals to 3 is 1 over 3 to the power 4 minus 1 over 4 to the power 4. So you can continue until n. So for the n part, I would suggest you start from at least n minus 1. So 1 over n minus 1 to the power 4 minus n minus 1 plus 1 to the power 4. So that's just n to the power 4 plus 1 over n to the power 4 minus 1 over n plus 1 to the power of 4. So you can see all the terms in the middle just cancel out. So we only have the first and the last terms remaining. Simplifying those, you would just get 1 minus 1 over n plus 1 to the power of 4. So in short, for method of differences, figure out what the pattern is and the common terms that you can strike off and the location of the common terms that you can strike off, so that you would either end up with, just two terms. All right. So yeah, this would be our final answer for this second part. Let's move on to the last part. Okay, so for the last part, we're told to deduce the value of the summation from r equals to 1 all the way to infinity. So this is just another way of asking us to find the limit as n approaches infinity of 1 minus 1 over n plus 1 to the power 4. So to evaluate this, you just substitute infinity into n. So infinity is just a really big number. So as the denominator gets really big, this whole term in here, the fraction, will be basically 0. So this would just be 1 minus 0, and your answer would just be equals to 1. Yeah, so with that, let's move on to the next question. Okay, so for this question, we're given two matrices A and B. So this is A and this is B. And for the first part, we're told to give full details of the geometrical transformation on the XY plane represented by A. So basically, you have to state what transformation the matrix A does on a 2D XY plane. Okay, so let's start by observing the elements in the matrix A. So you can see that this diagonal here, like this is the first thing that you should look out for. If both of them are 1, you can forget about stretches in the X and Y direction. Okay, so if both of these are 1, there's no stretches in the X and Y direction. Okay, right. And now check the other diagonal. Okay, so you have 3 over 2 at the top and 0 at the bottom. So if you see a non-zero number at the top of this diagonal, this means that this is a shear. Okay. Yeah, so let's write that down. So this is a shear, and specifically this is a shear with the x-axis fixed. So what I always like to do is I associate the top row with the x-axis or the x coordinate or okay, just x-axis, and the bottom two, the bottom row with the y-axis, regardless of whether it's a stretch or a shear. Okay, yeah. So yeah, this is a shear with the x-axis fixed, but we're not done yet. We also have to put like an example of like a point being transformed by this matrix. Okay, so to do that, just get any random point. Yeah, it's best if you don't choose any points with zeros or ones. Like both of them cannot be ones and cannot be 1 and 0. Yeah. So I'm gonna choose 2, 1. Okay. Yeah. And if you just quickly type it into your calculator, so 1 times 2 plus 3 over 2, uh, yeah, you would get 7 over 2. And then the bottom row, 2 times 0 plus 1 times 1, you get 1. So what do you notice about these 2 points? Well, you can see that the y coordinates of the points, they are unchanged. Only the x coordinates have changed. So that means the x-axis is fixed. So here's a quick little sketch for you. So the original point 2, 1, let's say it's around here. 7, 1 would be somewhere up here. Wait, no, sorry. No, it's supposed to be horizontal. Yeah. So this is the vector of the position vector of the original point. This is the position vector of the new point. So you can see that like it has sheared in the horizontal direction with the x-axis fixed. So yeah, basically you can just write with your original point 2, 1, transformed, I believe. Wait, no, translated. Transformed into 7 over 2, 1. Something like this. Yeah. So these are the 3 parts where whenever you have to describe a matrix that describes a shear transformation. Okay. So yeah, this would be our answer for our first part. Let's move on to the second part. Okay, so before I start for the next part, I believe it's more appropriate to say transform onto or mapped onto instead, you know? Yeah, that's the main thing that I want to like rectify. Yeah, so part B is really similar. They told us to just give the full details of the geometric transformation represented by B. So let's observe what B is. So first check this diagonal. So you can see both of them is 1. So if both of them are 1, that means there's no like stretching in the XY direction. Okay? Okay, so that is done. Now check this diagonal. Now this diagonal, you can see that it's the opposite. So our top row in this diagonal, which is the x-axis, that is 0. And, oh, sorry. And this time our bottom row element is actually the non-zero part. So this time it's our y-axis that is being fixed. Okay, so we can write shear y-axis fixed, and then you can write down the example of a point that is being transformed. Okay, wait, let's try with this. Okay, this one, I believe 1 times 2 times 0 times 1, that is also 2. And then 3 times 2 that is 3, and then 1 times 1, that is 4. So 2 of 4. Wait a minute. 1. Okay. Yeah. So we can say with 2 comma 1 mapped onto or transformed onto 2 comma 4. Yeah, so this would be our final answer for this second part. Let's move on to the next part. Okay, so for this part, we're told that the triangle DEF in the XY plane is transformed by AB. So this is the keyword transformed by AB onto triangle PQR. So basically, DEF, after being transformed by AB, it became a triangle PQR. So we have to show that these two triangles, they have the same area. Okay, so for the area, the areas of these two triangles, they can be related in this formula. So DEF, wait, no, PQR is the new one that was, like it's the aftermath, right? So area of PQR is just the determinant of AB times the area of DEF. So if they have the same area, that means the determinant of AB has to be equals to 1. So you basically have to prove that, okay? So first of all, we need to find what AB is exactly. So A is 1, 3 over 2, 0, 1. And then B is 1, 1, 0, 3 over 2. You can quickly use a calculator for this, but I'm just going to do it manually, okay? So the first element, that's the first row, first column. First row, first column. So 1 times 1, that's 1 plus 3 over 2 times 3 over 2, that is 9 over 4. So 9 over 4 plus 1, that is 13 over 4. And then the second one, first row, second column, 1 times 0, 0, plus 3 over 2 times 1, that's just 3 over 2. Okay, and then 0 times 1, and then the second row, first column, so this row, so 0 times 1 is 0, plus 1 times 3 over 2, just 3 over 2. And then we have 0, 1, and 0, 1, so 0 times 0 is 0. 1 times 1 is 1, so yeah, just 1. So this is our matrix AB. So now we're going to find the determinant of AB. So determinant of AB, just take the cross product of this diagonal first. 13 over 4 times 1 minus the cross product of the other diagonal, 3 over 2 times 3 over 2, which is 9 over 4. And that you would just get 4 over 4, which is equals to 1. So we can show the statement is true by saying since determinant AB is equals to 1, DEF and PQR have the same area. Sorry. Yep, so this would be final answer for this part. Let's move on to the last part. Okay, so for the last part, we're told to find the equations of the invariant lines through the origin of the transformation in the xy plane represented by AB. Okay, so this is a standard question that you must know how to do. So to do this question, first write down your matrix AB, the matrix that you're transforming with. AB is that whole thing, 13/4, 3/2, 3/2, and 1, and then place the points XY, like a general point along the line, and then those equal to a new set of points, big X and big Y, let's say. Now, since it is through the origin, we can substitute, Y for both of them just equals to mx. Similarly, big Y is just m times big X. Okay, so 13/4, 3/2, 3/2, 1 times x mx goes to x times m big X. Okay, so let's combine this into one matrix. So let's multiply. So 13/4 times x, that's 13/4x plus 3/2 times mx, 3/2 mx, then 3/2 times x plus 1 times mx plus mx. Yep, that is equals to x mx. Okay, so now we can, make it into a fraction. So just put like a denominator fraction line over both of them. Yeah, let me just erase that. Yeah, so put a fraction line. Three over 2x plus mx goes to x over x. So you can cancel out the x, same for here, and cancel out and factor out. And yeah, let's multiply both the numerator and the denominator by 4. So you get 13 plus 1.5 times 4, that is 6m over 1.5 times 4, which is 6 plus 4m equals to 1 over m. Yeah, so now just solve this as usual, cross multiply. So 6m squared plus 13m equals to 1 times 6 plus 4m, so 4m plus 6. Move everything over to the left-hand side, 6m squared plus 9m minus 6 goes to 0. Divide both sides by 3. So you get 2m squared plus 3m minus 2 equals to 0. Yeah, and try to factorize or use the quadratic formula. Okay, so you get 2m minus 1 times m plus 2 equals to 0. Then you get 2m minus 1 equals to 0. M equals to half. And m plus 2 equals to 0. M equals to negative 2. Therefore, our invariant lines would just be y equals to mx, which is y equals to half x and y equals to negative 2x. So these two will be our final answers for the last part as well as the entire question. Let's move on to the next question. Okay, so for this question, we're told to prove by mathematical induction that for every positive integer n, this result is true. Okay, so to do this, like for every proof by induction question, you're supposed to first substitute n equals to 1 and prove that it is true for that case, unless otherwise stated. Okay, so d2n plus minus 1, that's just 1. So just d dx times x cosine x. So just differentiate this as normal. So keep your x, differentiate your cos x minus sine x, plus differentiate your x and keep your cosine x. So you'll get minus x sine x plus cos x. Okay, now we're gonna have to make this equal to the right-hand side. Okay, so minus 1 to the power of n, which is just 1, so just minus 1 times x sine x minus 2n minus 1, which is just 1, but just write it as 2 times 1 minus 1 cosine x. Okay, yeah, so you can see that both the left and right hand sides, they're the same. So therefore, uh, case for n equals to 1 is true. Yeah, so that's the first step. Now you have to write your inductive statement. So basically, you just have to say that assume uh, true for n equals to k, where k is a positive integer. Yeah. And now this is where the main part begins. Now you're gonna have to let n equals to k plus 1. So you already made your assumption that this whole thing, when n equals to k, is true. So when you let n equals to k plus 1, you're gonna have to use the case where n equals to k. Okay, so let's start. So dx to k plus 1, so 2k plus 2 minus 1, 2k plus 2 minus 1, uh, x cosine x. Okay, so that is just 2k plus 1, 2k plus 1. Okay, so our main goal here is to make sure that our left and right hand sides, they follow this exact same format. So we want to make sure that in the end, our right hand side, our final answer is this exact same format with n equals to k plus 1. Yeah. Okay. So to start off, whenever you see a plus 1 in, the in proof by induction for differentiation, it just means that you differentiate it one more time. Okay. Okay, wait a minute. Mm, yeah, so you just differentiate it one more time. Okay, so we assume that it is true for the base case where n equals to k. Yeah, so we're going to Yeah, so this is just d dx of d dx of d2k minus 1. So this is d2k over dx2k, and this is d2k plus 1. I hope you get what I'm trying to say. Over dx 2k minus 1 of x cos x. Okay, so this is just the second derivative basically, but I don't really want to write that. Okay, so for this, just copy all this, the right hand side down, just replace the n with k. Okay, so you have minus 1 to the power of k times x sine x minus 2n minus 1 minus 2k minus 1 times cos x. Okay, yep. Okay, now we're gonna differentiate this entire expression. So this one is just a constant, so we can leave it out. Yeah, now just differentiate this. So x sine x, differentiating that. Okay, wait, let me bracket this. Okay, so differentiating that, you would get, yeah, keep the x cos x uh plus sine x minus okay, now differentiating the 2k minus 1 cos x, keep the 2k minus 1, and just differentiate the cosine x, which is just minus sine x. So minus minus, this one just becomes plus. Okay, all right. Okay. So let me simplify everything inside the bracket. Okay, so this is x cos x plus sine x plus 2k minus 1 sine x. So that's just 2k sine x. Yeah, okay, so now it's a lot simpler to differentiate. So this one again, it's a constant term, so you can leave it out. So minus 1k. And now you just have to differentiate this entire term. So x cos x, differentiating it, keep the x. Wait, no, let's keep the cosine x first. So cosine x and differentiate the x. So just cosine x and then plus, keep the x and differentiate the cosine x. So that's minus sine x. So this is just going to be minus x sine x. Then plus 2k. This one is a constant term, so you can leave it alone. And just differentiate sine x, you're going to get cosine x. Okay. Oof. Okay, so minus 1 to the power of k times cos x plus 2 k cosine x. You would get minus x sine x plus 2k plus 1 cosine x. Okay. All right. So to make it in the form of the right hand side here, Yeah, you can see this sign here is actually minus instead of plus, so we can start off by factorizing -1 from here. So factorizing that, you get -1 to the power of k times -1. So that's just -1 to the power of k plus 1 times x sine x minus 2k plus 1 cosine x. Yeah, let's see. Yeah, we're almost there. Yep, the n is replaced with k plus 1. We only have this part left to manipulate. Yeah, so this 2k plus 1 bracket thingy. Okay, so this is x sine x minus 2n, which is k plus 1 minus 1. So yeah, it's in the form of 2n minus 1 cosine x. Yeah. So yeah, that is exactly in this format of the right-hand side. And with that, we can say that since case for n equals to k is true, case for n equals to k plus 1 must also be true. And so with that, we can conclude, we can write a final concluding statement. Hence, using principle of mathematical induction, the above statement is true. Statement is true. Yep. So yeah, this would be a final answer for this entire question. Let's move on to next question. Okay, so for this question, we're told that the quartic equation, this has roots alpha, beta, gamma, and delta. And for the first part, we need to show that a quartic equation with the roots 2 alpha plus 1, 2 beta plus 1, 2 gamma plus 1, 2 delta plus 1 is equals to this. Yeah, so first things first, we notice that the roots in here, they're just basically the same versions of each other, you know? Yeah, so like you just like put the root in place of x, okay? So we can, use the substitution y equals to 2x plus 1. So in place of alpha, beta, gamma, or delta, we just put x since, they are roots of this quadratic equation. So like you can replace x with alpha as well as beta, gamma, or delta, but you can only replace it with those only. You cannot have alpha and beta in the same equation. I hope you guys, can understand what I'm trying to say. Yeah, so first step is to make this substitution. And before we make the substitution, you have to make x a subject. So you have 2x equals to 1, y minus 1, and x would just be y minus 1 over 2. So this is a substitution. Okay, so now just substitute into your quartic equation. So y minus 1 over 2 to the power 4 plus y minus 1 over 2 cubed plus y minus 1 over 2 squared plus y minus 1 over 2, that's x plus 1, oh, sorry, equals to 0. Okay, so simplify everything. So y minus 1 to the power 4 over 2 to the power 4. That is 16 plus y minus 1 cubed over 2 to 2 cubed, that is 8, plus y minus 1 squared over 2 squared, which is 4, plus y minus 1 over 2 plus 1 equals to 0. Okay, so to get rid of the denominators, let's multiply both sides by 16. So you get 16 times y minus 1 to the power 4 plus 16 over, divided by 8, that's 2. So 2 times y minus 1 cubed plus 16 times 1 over 4, that is 4, times y minus 1 squared plus 16 times half, that is 8, y minus 1 plus 16 equals to 0. Okay, yeah, now we're gonna have to expand out everything. Okay, so to expand this out, all these out, in fact, you can use the Pascal's triangle. So for the second power is 1, 2, 1, so this is 2, and for third power is 1, 3, 3, 1, and then for the fourth power is 1, 4, 6, 4, 1. Yeah. All right. So for the, let's start off with the fourth power. Okay, so start off with 1, so y to the power 4 minus 4y cubed times 1 plus 6y squared times negative 1 squared. So that's just plus 6y squared minus 4 times y times 1. So minus 4y plus minus negative 1 to the power 4, which is just plus 1. Okay. Okay. And then for the next one, y minus 1 cubed is just this. So you start off with y cubed and 3 times y squared negative 1. So that's just minus 3y squared. Then plus 3 times y times negative 1 squared, which is plus 3y, and plus negative 1 cubed, which is minus 1. Okay, and plus 4 times y minus 1 squared, so that's just y squared minus 2y plus negative 1 squared, which is just plus 1, and 8y times minus 8 plus 16 equals to 0. Okay, so let's expand everything out. Wow. Okay, so 16y to the power 4. Okay, let's group all the y cubed and y squared terms. So y cubed, we have 16 times minus 4, and we have 2 times y cubed yeah, that's all. So 16 times -4 plus 2, that is -62 y cubed. And let's do for y squared. So 16 times 6. Yeah, 16 times 6. And 2 times -3. So -6 and 4 times y squared and plus 4. You would get plus 78 y squared. Okay. And then for y, we have 16 times -4. So 16 times -4, that is -64. And 2 times +3. So -64 plus 6. And we have 4 times -2y, which is -8. And we also have plus 8y plus 8. So that is, yeah, minus 58y. Okay, now let's do the whole numbers. So 16 times 1, that is 16. 2 times -1, that's -2. 4 times 1, that is +4. And -8 plus 16, that is +26. Goes to 0. For this, okay, so I just realized I made a mistake here. Okay, so you're not supposed to have the 16 in here. Okay, so wait a minute. Let me just remove all the markings. Uh, yeah. So using the same method, so you're supposed to have y to the power 4, and for the y cubed terms you have -4, 2y cubed, so -4 plus 2. Yeah, so that is -2y cubed, and then for the y squared term you have plus 6y squared times 2 times -3y squared, so that is 6 minus 6y squared plus 4y squared, which is just plus 4y squared. And then you have minus 4y, 2 times 3y. So minus 4 plus 6y, 4 times -2y. So minus 8y plus 8y. That is plus 2y, and you also have 1 minus 2 plus 4 uh, minus 8 plus 16, which is plus 11 equals to 0. Yeah, and that's the exact equation that we have to get, so we can write shown. Yeah, so with that, we can finally move on to the next part. Okay, so for this next part, we're told that the sum of all the roots basically to the power of n, is denoted by Sn. So for this part, we need to find the value of S2, which is basically just the sum of the square of the roots. Okay, so to find S2 for any, equation, whether it's quadratic, cubic, or quartic, the same formula applies. So it's just sigma alpha squared. So sigma alpha is your sum of roots, just your roots, minus 2 times sigma alpha beta. So sigma alpha beta is your the sum of your root pairs. So you take two of your roots, you multiply them, and then you add them with another root pair and then you just add all the possible root pairs products. Okay, yeah. So to find this, it's just minus b over a squared minus 2c over a um, minus b minus so b is like the coefficient of the y cube term. So that's just 2. So 2 over 1, yeah, 2 over 1 squared minus 2 times c. So c is the y squared term. So that's just 4. So 2 square is 4 minus 8, which is negative 4. So this would be final answer for the second part. Let's move on to the last part. Okay, so for the last part, we are told that S3 is negative 22, and using that, we need to find the value of S4. So for like higher summations, yeah, so like S cube and S4, instead of using the general formulas like we did in the previous part, you can just substitute them straight into the equation that you're working with, that the summations are related to. Okay, so this is our equation. Okay, so the y to the power 4, you can just replace it with S4. So this S4, and same for the y cubed as well as y squared. You can replace them with S3 and S2, right? So minus 2 S3 plus 4y squared. So plus 4 S2 plus 2y to S1, which is just the sum of the roots. And finally, plus 11 for, so for 11, it's just 11S0 equals to 0. So S4 minus 2S cubed minus 2 times negative 22 plus 4S2. So S2 is negative 4 plus 2S1. S1 is also just 2 and plus 11 S0. So S0 is just to the power of 0, so it's just 1 plus 1 plus 1 plus 1. So that is just 4. So that's just 11 times 4 equals to 0. Okay, then you just rearrange everything. You'll get minus 44 minus 4 plus 16 negative 44. You'll get negative 76 as your final answer. Let me double check that. 44 minus 16 plus 4 plus 44. Yep, you'll get negative 76 as your final answer. So yeah, with that, we can move on to the next question. Okay, so for this question, we're told that the plane pi1 has this vector equation. And for the first part, we need to find equation for pi1 in this form. So we need to find the Cartesian equation of pi1. Okay, so to find the Cartesian equation for any plane, you need to first take two direction vectors on the plane. So we already given for this plane, which is this and this. Okay, so let's take I, J, K. We just have to take the cross product of those two direction vectors to find our normal vector to the plane. So you have J plus 2K, which is just 0I, plus 1J plus 2K. And then you have I plus 3J plus K, which is just 1, 3, 1. So you can use your calculator to easily find this out, but I'm just going to do it the manual way. So to get your I, you cover these two. Wait, sorry. Cover these two, and then you take your 1, 2, 3, 1. Like you take the determinant of that part only. Okay, and then for your J, you have to put a minus sign. So minus J, take the determinant of, cancel out all the rows and columns that have J in it, and then you take the determinant of 0, 2, 1, 1. And then for the K, just plus K of 0, 1, 1, 3. So this is going to be I, 1 times 1 is 1, minus 2 times 3 is 6, minus J, 0 times 1 is 0, minus 2 times 1, that's minus 2, plus K, 0 times 3 is 0, minus 1 times 1 is minus 1. So you get minus 5I plus 2J minus K. Or in column vector form, you'll just be minus 5 to minus 1. Okay, all right. Okay, so now we can fill up our the ax plus by plus cz. So a is minus 5, x and by is plus 2y, and then cz is minus z equals to d. Okay. So to get our D, we just have to substitute a point on the plane, and that one is just given by the first position vector on the vector equation of the plane. So we can substitute x equals to -3 and y equals to -1 and z equals to -1 as well. So you get 15 minus 2 plus 1, which is 14. Okay, so yeah, so this is minus 5x plus 2y minus z equals to 14. So that's going to be our final answer for this first part. Let's move on to the next part. Okay, so for this second part, we're told to find the perpendicular distance from the point with position vector minus I minus 2. So this is the coordinates of that point to pi1, the plane. Okay, so the perpendicular distance is basically just the shortest distance. And to find it from a particular point to the plane, we first have to make a little sketch. So this is the plane pi1, and this is the vector that's normal to it, which we found just now, to be minus 5 to minus 1. And let's say this is the point. that we're interested in. So this is the position vector that we want to find our perpendicular distance from here to here. Okay, so this is -1, 0, 2. And this point we don't know. So basically, we're just going to find the distance between these 2 points. Okay, so first we need to find this point first. Okay, so this point, it's along the normal vector to the plane as well as on the plane. So to, represent this point, we're going to use the vector equation of the normal, the line, the vector equation of a line for the normal. Okay, so I'm just gonna replace it with x, y, z. Position, the initial starting vector is just the position vector -1, 0, -2 plus mu, which is a scalar of the direction vector, which is the normal vector, -2, -5 to -1. And this is just -5 mu -1, 2 mu minus mu -2. So that's x, y, z. Yeah, now we need to substitute these into our vector, our equation for the plane, because it's also on the plane. So -5 -5 mu -1 plus 2 times 2 mu minus z. So minus mu minus 2 equals to 14. So expanding everything, you get 25 mu plus 5 plus 4 mu plus mu plus 2 equals to 14. So yeah, this is just 30 mu equals to 14 minus 2 minus 5. So that's just 7. Then mu is just going to be 7 over 30. Okay, so the line, okay, so the point that we're looking for is just 5 times 7 over 30 minus 1 times 2 times 7 over 30 minus 7 over 30 minus 2. And this is just a bit dark. 30 minus 1 minus 13 over 6. 7 over 15 minus 7 over 30 minus 2 minus 67 over 30. Yeah, so this is our unknown point, okay, that we're looking for. All right, now we need to find the distance between these 2 points. So we need to find the vector between these 2 points. Okay. Oh wait, we can just, oh yeah, the vector between these 2 points is just this. Yeah, I just realized. Yeah, I don't have to actually find our unknown point. I mean, you can, and then you can subtract, but in the end, you'll just get the point, the direction vector. Okay. Yeah, so direction vector is just negative 7 over 30 times -5, -7 over 6 times 7 over 15 times negative 7 over 30. Yeah. And now you can finally find the distance. So just use your Pythagoras theorem and find the magnitude of this vector. Minus 7 over 6 squared plus 7 over 15 squared plus negative 7 over 30 squared. Wait a minute. Plus negative 7 over 30 squared. So this is just 7 over 30 square root 30. So yeah, this is our final answer for this part. Let's move on to the final part. Okay, so for the last part, we're told that the plane pi over 2 has this Cartesian equation, and we need to find the vector equation of the line of intersection of pi 1 and pi 2. Okay, so to find the vector equation of the line of intersection, you need to first find the direction vector of the line of intersection, which is just the common perpendicular of the normals to the planes. Okay, so first just find the common perpendicular of the normals to the planes. So for pi 1, it is negative 5 to negative 1, negative 5 to negative 1, and pi 2 is 3 to negative 1. So for I, it's just 2, negative 1, 2, negative 1, then minus j, uh, minus 5, minus 1, 3, negative 1, plus k, you have minus 5, 2, 3, 2. Yeah, so for I, you have 2 times negative 1, which is negative 2, minus negative 2, minus j, negative 5 times negative 1, which is 5, minus negative 1 times 3, which is minus 3, and then plus k, which is negative 5 times 2, which is negative 10, minus 2 times 3, which is 6. Yeah, so this one is just going to be 0i minus 8j minus 16k. And simplifying this is just the same as 0, negative 8, negative 16. Simplifying, you just get 0, 1, 2. So this is the direction vector of the line of intersection. Okay, so now for vector equation, there has to be a position vector of a point along the line, as well as the direction vector of that line. So now we need to find a common point between pi 1 and pi 2. Okay, so to do that, yeah, let's copy down the vector, the Cartesian equations of both planes. So minus 5x plus 2y minus z equals to 14. So this one is pi 1. Pi 2 is 3x plus 2y minus z equals 40. So you can see that both of them, they're the exact same. So you can just equate both of them together. They get 3x plus 2y. Oh wow, when the two y's they're the same. Okay, so now we have 5x equals to 3x. Okay, so since we ended up with this equation, the only value of x that is valid for that makes this equation valid is x equals to 0. So we're just gonna sub x equals to 0. Okay, then you would get 2y minus z equals to 14. And then you would get z equals to 2y minus 14. And this and now you can just sub, let's say 1, y equals to 1. Then z you would get 2 minus 14, which is minus 12. And therefore, a common point that you can get is 0, 1, negative 12. Yeah. But if you substitute 2 times 7, yeah, you also get that. Yeah, so this is one common point. And therefore, the vector equation of the line is just 0, 1, negative 12 plus lambda times 0, 1, 2. Or in IJK format, that is j minus 12k plus lambda j plus 2k. So this would be a final answer for this last part as well as the entire question. Let's move on to the next question. Okay, so for this question, we're told that the curve C has this polar equation r equals to sine 3 theta for theta between 0 and pi over 3. So for the first part, we need to sketch C and state the equation of the line of symmetry. So this is the keyword, line of symmetry. Okay, so to sketch a polar curve, you need to draw your initial line, which is the same as your x-axis. So this initial line, the value of theta will just be equals to 0. Okay, so to draw your polar, okay, so now we are gonna plot, sketch a polar curve. So to sketch a polar curve, just substitute the values of theta within this range. So substitute 0 first, you would get the 0. So r equals to 0, that means you start right here. And then as you increase the value of theta, so will your value of r will also increase. So that means for every increasing angle until about pi over 3, which is about 60 degrees, your value of r would just keep increasing. Something like this. Yeah. Yeah, something like this. Yeah, think that can work. I mean, if you want, you can also extend it a bit. Okay, yeah. Oh wait, no, I don't think it's supposed to be like this. Yeah, so yeah, so it's actually supposed to circle back. Give me a while. Yeah, it's actually supposed to circle back. So it starts initially like this, increases, then reach a maximum point, and then it will go back. So form like a flower petal shape. So there would be a point where it reaches its maximum. So you need to So this would be the line of symmetry. So we need to find out what value of theta this is. So the value of theta that it occurs at is when r is at its maximum value. And since r is equals to sine 3 theta, we need to know the maximum value of sine 3 theta. And that's like really simple. It's just 1. Okay. So if you do the math, you'll get 3 theta equals to pi over 2. Yep. Then pi over 2 divided by 3, you would get pi over 6. So this is just the halfway point, basically. So yeah, you can write it down here also. And yeah, with that, let's move on to the next part. Okay, so for the second part, we need to find the exact value of the area of the region enclosed by C. Okay, so to find the area enclosed by any polar curve, we're going to use this formula, half integral of r square d theta. And the limits are basically going to be the limits of theta, the angle. So in this case, our limits are from 0 to pi over 3. Okay. Okay, so yeah, this is just going to be half integral of pi over 3, 0, sine square 3 theta d theta. Okay, so now we need to integrate sine square 3 theta. So to do that, you need to use your double angle formula. So yep, go to pure maths under trig. Yeah, you can see so you can see cos 2 theta, this exact formula. So 1 minus 2 sine square A goes to cos 2A. So you make sine square A your subject, you would get 1 minus cos 2A over 2. So we're going to substitute this exact result back into there. So this is going to be 1 minus cosine 2A, which is 3 theta, over 2 d theta. So you can remove the half, and you have 1 over 4 integral of pi over 3, 0, 1 minus cosine 6 theta d theta. This is 1 over 4. Then integrating this, integrate 1, you'll get theta minus, and then integrate cos 6 theta. It's just going to be 1 over 6 sine 6 theta with the limits. Okay, so with the limits, we'll get 1 over 4 times pi over 3 minus 1 over 6 sine 6 times pi over 3. So that is 2 pi minus 0 plus 1 over 6 sine 6 times 0. So sine 0, that's also just 0. Yeah, so so this whole thing is just 0. So you simplify, you get pi over 12. 1 over 6 times sine 2 pi. 2 pi is 180. So that's also 0. So it's just pi over 12 lah. Yeah. Yeah, unit squared. Yeah, so this would be our final answer for this second part. Let's move on to the next part. Okay, so for part C and D, we're told that we can use this identity. So just take note of this. And for part C, we're supposed to find the maximum distance of a point on C from the initial line. So let's make sense of this. Like, what do they mean by this distance from the initial line? So when we sketched, I mentioned that this theta equals to 0 is the initial line. Initial line is basically like the x-axis. So they just like want to know what's the maximum distance from here to any point here. So yeah, this is the distance that they're asking us to find. And if you take this back into your Cartesian coordinates, this is like finding your maximum y value, right? So yeah, that's also the exact same logic also applies here. So to find this, we need to find dy d theta and equate it to 0, just like what we do in Cartesian. You want to find the maximum point, you make dy dx equals to 0 as well. Okay, so first we need to find the equation for y in terms of our polar equation. So you must know this, that y is just equals to r sine theta. Okay, so r for us is equals to sine 3 theta. So this is sine 3 theta sine theta. Okay. Okay. So uh okay, let's use the identity because we're gonna have to differentiate it. So sine theta times 3 sine theta minus 4 sine cube theta equals to 3 sine theta squared minus 4 sine theta to the power of 4. So this is our y equation. And now we're going to find dy d theta. So just differentiate it. So to differentiate this, to differentiate sine squared, bring down the power minus 1 from the original power and differentiate sine theta, which is just cos theta. Same for 4 sine theta to the power 4. So keep the 4, differentiate sine theta to the power 4 by bringing down the 4, subtracting 1 from the existing power, and multiplying it by cosine theta. Okay, so you would get 6 sine theta cosine theta minus 16 sine cube theta cos theta. Yeah, now just equate it to 0. So 6 sine theta cosine theta minus 16 sine cube theta cos theta equals to 0. So I can see that we have 2 as common factors, so sine theta and cosine theta. So we can factor out 2 sine theta cos theta. Yeah, I'm not canceling out anything at this point. Okay, just to be safe. So 3, oh my goodness. Okay, so 3 minus 8 sine square equals to 0. Yeah, so you should know that 2 sine theta cos theta, if you go to your MF19, yeah, 2 sine A cos A is just 2 sine 2A. So this is just sine 2 theta times 3 minus 8 sine square theta equals to 0. But we know that sine 2 theta cannot be equals to 0. If it is equals to 0, then theta has to be equal to pi over 2. And we know that theta cannot be pi over 2. Like the maximum value is only pi over 3. So we can cancel that out. And we have 3 minus 8 sine squared theta equals to 0. And we have sine square theta equals to 3 over 8. Okay. Yeah. All right. Now we need to take the square root. So sine theta, taking square root, you would get square root 3 over 2 square root 2. I rejected the negative one because, again, our domain for sine theta is not negative. So it only can be positive. Okay. Yeah. And now, wait, it was maximum. Oh, wait. Yeah, we just want to find the maximum distance. Okay. Yeah. So we need to find the value of theta. So just substitute it directly into the equation. So 3 sine squared theta. So 3 square root 3 over 2 square root 2 square minus 4 times square root 3 over 2 square root 2 to the power of 4. Root 3 over 2 square root 2, 3 answer to the square minus 4 answer to the power of 4. Yeah, you'll get 9 over 16 units as your final answer. So yeah, this would be our final answer for part C. Let's move on to part D. Okay, so for the final part, we need to find a Cartesian equation for C. Okay, so to convert a polar equation into a Cartesian equation, you need to know these three identities. So the first one is x squared plus y squared equals to r squared. And the second one is y equals to r sine theta. And the third one is x equals to r cosine theta. Okay, so let's write down our original polar equation, which is just r equals to sine 3 theta. And to make the conversion easier, we're going to use the identity that they gave us. Okay, so r equals to 3 sine theta minus 4 sine theta cubed. Okay, cool. Okay, so I'm just going to express everything in terms of r first. So sine theta can just rewrite as y over r minus 4 sine cubed theta can rewrite as y cubed over r cubed. And now let's get rid of the denominator, r cubed. So you can do that by multiplying by r cubed on both sides. You'll get r to the power of 4 equals to 3 times y times r squared minus 4y cubed. Yeah, okay. And then you would get r to the power of 4, which is just r squared squared. So this is just x squared plus y squared whole thing squared. And you have 3y times r squared, which is 3y times x squared plus y squared minus 4y cubed. Yeah, and then just expand and simplify this even further. You get 3x squared y plus 3y cubed minus 4y cubed. So that is minus y cubed, if I'm not wrong. Yep, that is minus y cubed. So I believe we can stop here and conclude this question as our final answer. So with that, let's move on to the last question. Okay, so for this question, we're told that the curve C has this equation. So curve C is a rational function. For the first part, we're told to find the equations of the asymptotes of C. Okay, so for the horizontal asymptote, check whether the equation is whether the rational function is a proper fraction or an improper fraction. So since it's a proper fraction, the horizontal asymptote will just be y equals to 0. As for the vertical asymptote, to find it, just equate your denominator, which is x squared plus 3x plus 1 with 0. So, okay, let me try factorizing it. If it doesn't factorize, but has no real solutions. Okay. Um, okay, unfortunately it does. Okay. So we need to use the quadratic equation. So minus b, which is plus 3, plus minus b squared, which is 3 squared, minus 4 times a, which is 1, c, which is also 1, over 2 times a, which is 1. Then you get x equals to negative 3 over 2 plus square root 5 over 2, and x equals to negative 3 over 2 minus square root 5 over 2. Yeah, so these two are our equations of our vertical asymptotes. Okay, let's move on to next part. Okay, so for this second part, we need to show that C has no stationary points. Okay, so to show this, we need to first find our dy dx and equate it to 0. Sorry, give me a moment. Okay, so as I was saying, we have to make dy dx equals to 0. So let's start by finding dy dx. So to find dy dx, we need to use our quotient rule. Okay. So first square the denominator. Now keep the denominator and multiply by the derivative of the numerator, which is just 1 minus the numerator times the derivative of the denominator, which is just 2x plus 3. Okay. Okay, now let's try to expand the numerator a bit. So plus 1, then minus 2x times x, that's 2x squared. And x times 3, that's 3x, and 2 times 2x, that's 4x. So that's total 7x plus 2 times 3, that is 6 over x squared plus 3x plus 1 squared. So simplifying, you'll get minus x squared minus 7x plus 3x, which is minus 4x plus 1 minus 6, which is minus 5 over x squared plus 3x plus 1 squared. And now we equate dy dx with equals to 0. We'll get x squared plus 4x plus 5 equals to 0. So if you type into your calculator, try to solve it using a calculator, you're going to get imaginary solutions. So you can say no real solutions. Okay. So therefore you can say that dy dx cannot be equals to 0. So C has no stationary points. So this would be our final answer for this second part. Let's move on to the next part. Okay, so before I start with this part, to make your reasoning more strong, you could use the discriminant for this. So the discriminant for this is just b squared minus 4ac. So b squared is 4 squared minus 4, then a is 1, c is 5. So that is all less than 0. So therefore, there's no real solution. Okay, so let's move on to part C. Okay, so for part C, we need to just sketch C, stating the coordinates of intersection with the axes. Okay, so to sketch C, we first start off by drawing our x and y axes and labeling our asymptotes. So this is one asymptote, y equals 0, and our vertical asymptotes are uh, minus, minus 3 over 2, minus 5 over 2, that is minus 2.61. So I'll place that one in here. This is x equals to minus 3 over 2 minus square root 5 over 2. And then now for the conjugate, okay, that's also negative, but it's much closer. So around here, so that is x equals to negative 3 over 2 plus square root 5 over 2. Yeah, so this is our, these are our three coordinates, I mean asymptotes. Okay, all right, so now, since they said that there are no stationary points, okay, let's start off by finding the coordinates of the intersection. So let's start off by finding the y-intercepts. So to find the y-intercepts, just substitute 0 into the original equation. You get 2 over 0 squared plus 3 times 0 plus 1. You get 2. Okay, so 2, you can say it's like around here. So this is the x coordinate, sorry, the y coordinate, the x coordinate is 0, y coordinate is 2. Okay, and then for the y coordinates, just equate the numerator with 0, then you'll get x equals to negative 2, which is somewhere here. Yep, it's somewhere here. This is negative 2. Okay. Yeah, this is one of the other, yeah, this is like the only coordinate. Okay. All right. Yeah, so since there are no stationary points, let's do for this branch where the asymptote is the y-axis. Same for this. Yeah, and okay, so we need to figure out how this goes. So it can either go like this or like this. So to figure that out, just substitute a value greater than -2, but between the range. So we can substitute like -1, like x equals to -1. So -1 plus 2, -1 squared plus 3 times -1 plus 1, you'll get -1, which is somewhere here. So this can probably be something like this. Yeah, so this is how it can be like. Yeah, so this is our sketch of C, right? So we can write the coordinates of the intersection points 0, 2, and -2, 0. So yeah, this is our final answer for this part. Let's move on to the next part. Okay, so for this part, we need to sketch the curve with the equation, this modulus equation of this. So basically, we just have to sketch the absolute version of the curve that we sketched here. So to do that is very simple. You just reflect whatever is below the x-axis above the x-axis. Okay, so let me sketch the axes. So this is the x-axis, is the y-axis. Asymptotes. By the way, when you're sketching, please use a ruler. Okay, so the one on the left, this left branch, it's all below the x-axis, so we need to reflect it back up. So reflecting back up, it will just look something like this. And then for the branch in here, the one that goes like this, okay, I'm going to, yep. Yeah, and then it goes down. We need to reflect the one that goes down like this. Okay, wait, that's not too good. So it goes. Wait. Oh, wait. Let me see. Okay, so it's more like this. Yeah, and okay, that one, the other one, we can just leave it as it is. Okay, just yeah. Yeah, so this is our curve. Y equals to the modulus of x plus 2 over x squared plus 3x plus 1. Yeah, so this is our coordinates. So this is -2. Oh my goodness, -2. And this is +2. Yeah, so yeah, this is our final answer for this part. Let's move on to the last part. Okay, so for this last part, we're told to find in exact form the set of values of x for which this modulus equation is more than 2. So for this, we need to use the sketch that we made in our previous part. Okay, so to do this, we need to first find the critical points with which the line y equals to 2. That's not a really good sketch. Yeah, this line y equals to 2, or this graph is less than 2. So to find that, we need to first equate x plus 2. Okay, wait, let me change color. Sorry. Yeah, so we need to first find the critical points with basically the intersection points for which this modulus curve is equal to 2. Okay, so we need to find all the intersection points. And as you can see, there's like 3 of them. Okay. Okay, so to solve this, we'll do it without the modulus sign first. Okay. So x plus 2 over x squared plus 3x plus 1 equals to 2. You get x squared equals to 2 times x squared plus 3x plus 1. And you get 2x squared plus 6x minus x, which is 5x, plus 2 minus 2, which is just 0. Yep. And yeah, you can just factorize the x. So x times 2x plus 5. So 0, you get x equals to 0. And 2x plus 5 equals to 0. X is minus 5 over 2. So these are our two critical points without the modulus sign. And on our graph, these would be this point and this point, because these two branches of the curve, they were also available in the original sketch without the modulus sign. So it's like this and this, okay? Yeah, so I believe it's best to label it. So this is minus 5 over 2, and this is 2. Yeah, all right. Now we're gonna find the other point, okay? So we'll just put the negative sign for this one. So x plus 2 over x squared plus 3x plus 1 equals to 2. Then you get x plus 2 equals to minus 2 times x squared plus 3x plus 1. Then this one you get 2x squared minus 6x. So plus 6x plus x, that is plus 7x plus 2 plus 2, which is plus 4 equals to 0. Yeah, and this one you can just try to factorize, or if it doesn't work, you can also, okay, unfortunately it doesn't factorize, so we need to use a quadratic formula. So minus b, so minus 7 plus minus b squared, which is 7 squared, minus 4a times 2, and c, oh no, sorry, times 4 over 2 times a, 2 times 2. Okay, and then you would get x is equals to minus 7 over 4 plus squared 17 over 4. And you would also get x is equals to minus 7 over 4 minus square root 17 over 4. Yeah. So these two are our other two critical points. Let's label them. So it's basically this point and this point. So this one is obviously the one with two negative signs. Minus 7 over 4 minus square root 17 over 4. And then this one is minus 7 over 4 plus square root 17 over 4. Yeah. Okay, you know what? I don't think I need to label that. Okay, yeah, so in the exam, whenever you label, please use a pencil so that you can erase it easily enough. Okay, so yeah, so we need to find the values of x for which this equation, the modulus, is more than 2. So more than 2 is basically between here and here. So I'm going to shade it, as well as between here and here, as well as between uh, here and here. Yeah. Yeah, that's more than 2. Yeah, as well as from here to here. Yeah, so so the first region is for x more than this point here, but less than the asymptote, which is, oh my goodness, so tiring. Square root 5 over 2x minus 2 plus square root 5 over 2x. Yeah. What's the, oh wait, there's no x. Sorry. Yeah, so the first region is between minus 7 over 4 minus 6 minus square root 17 over 4 bit less than x. Yeah, that like this lower limit, and uh minus 3 over 2 minus square root 5 over 2. Yeah, but then it is not inclusive, obviously. Okay, so that's the first inequality. The second one is between this one, negative 5 over 2, and the same sketch. Okay, so negative 3 over 2 minus x. Yeah, or maybe we can just combine these two. Yeah, since they have the same limit. Yeah. Yeah, and between negative 5 over 2, where x isn't equal to the asymptote, negative 3 over 2 minus square root 5 over 2. Yeah, so that is the first one. And then the second one is from here to here. Yeah, so between 0, wait, between square root between minus 7 over 4 plus square root 17 over 4 and 0. Yeah, 0. Excluding where x is not equals to 3 over minus 3 over, oh my goodness. Where x is not equals to minus 3 over 2 plus square root 5 over 2. Yep. Yeah, so this is our second inequality. And yeah, I believe these two are final answers for this entire, or this part was the entire question. And yeah, we've also come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe to this channel for more future past paper solving videos for A-level maths and further maths. If you have any questions, queries, or doubts, or any feedback, please feel free to leave them down in the comments below. And by the way, if you're doing A-level maths or mechanics with your statistics, as well as further maths, I offer tutoring on that. If you're interested, please check out the first link in the description box or the first link in the pinned comment. And with that, I'll see you guys again next time. Okay, thank you.